is Jonah Wade, and this is my video presentation on charged tapes.
The purpose of this experiment was to create a model for two pieces of tape and determine the electric force from their charge and the effect that force had. It was also to determine the electric field of the tapes and the charges that came along with it. In doing this, it was hoped that I would develop a more comprehensive understanding of how objects and charges interacted. The physics principles used in this experiment are Coulomb's law, which state that electric force is inversely proportional to the distance between objects and directly proportional to the charge of those objects. The force of gravity was also used in this experiment, which is simply stating that the force is equal to the mass times that gravitational constant. And lastly, Newton's second law was used in this experiment to show that if there is no change in momentum, then there is no change in net force. The results of this experiment showed that the pieces of tape had a positive charge, and which led them to repel each other, as well as attract a pin that was known to have a negative charge. The charge of the tapes was found to be 1.4 e to the negative 8 coulombs. The first part of this experiment was to determine the charge of the tape. First, to do this, 0.2 meters of tape were measured out and stuck on a flat surface. This was called the base tape. Then, two more pieces of tape of the same length were measured out and then folded onto each other slightly at the end. This created a handle, and these pieces of tape were called the U-tape. The pieces of U-tape were then stuck onto the base tape and ripped off quickly. The two pieces of U-tape, after being ripped off the base tape, were then moved towards each other, and their interaction was observed. Next, a clear plastic pin was run through hair to develop a negative charge on that pin. The pin was then placed close to the U-tape, and the interaction was observed as well. The results of this experiment showed that the pieces of U-tape repel each other, which showed that they must have the same charge. The two pieces of U-tape were also attracted to the negatively charged plastic pin, which showed that the tape must be positively charged. We know that they couldn't just be attracted to the negative pin because they were neutral, as they repel each other, which means they do have a charge. The next part of this experiment was to determine the actual amount of excess charge on the U-tape. So first, two more pieces of U-tape were made, and one of the pieces was suspended between two objects of the same height. Then a ruler was placed upright beside the pieces of tape to easily take measurements. The second piece of U-tape was brought towards the suspended piece of U-tape, and the distance of the two was observed in doing so. And during this, we were keeping a very close attention on the distance between the tape and if the suspended piece of tape began to float. After this, from this experiment, we saw that the tape began to rise at approximately when the two pieces of tape were 0.03 meters in proximity. This is because the two pieces of tape were of the same charge and repelled each other. In this experiment, there were some assumptions made. Like in the model, the tape was actually treated as a singular point located at the tape's center and not as its full surface area. The two pieces of U-tape were also assumed to have an equal charge when it may not have been, and air resistance was also ignored. Here are some quick values that I used for the calculations, and here are the calculations themselves. A computational model was created to show this experiment.
Two spheres were created to represent the two pieces of tape, and then a function was made to determine the electric field of those spheres. Here's what that computational model yields, and as you can see, the green arrow shows the electrical force, and the yellow arrow shows the force of gravity. It also shows the charge of the tape, the missing electrons, and the ratio of electron to atoms, which all match up with my calculations done by hand. In this experiment, there were some potential causes of inaccuracy. The first three are previously listed in the assumptions slide, and it's also possible that too much contact was made with the tape before the two pieces of tape were brought together. And the measurements were also taken by the naked eye, which could have led to inaccurate measurements. In this experiment, there were some additional questions that need to be asked. For example, what if electrons had a positive charge and protons had a negative charge? If that were the case, then the pin in this experiment would be repelled instead of attracted to the tape, as it would be the same charge as the two pieces of tape. There's also the question of why is it important to handle the charges of tape as little as possible? Now, this goes back to the potential causes of inaccuracy of there potentially being too much handling of the tape before the experiment was observed. This is because tape can lose its charge if it comes in too much contact with neutral objects, and electrons can be transferred when the charged objects make contact with neutral objects.